Hello everyone, welcome back. Today we are going to fine-tune our model by adding more layers. Let us deep into it. First, we initialize our sequential model, which is like a blank canvas waiting for us to add layers. We will call it model 2. Now let's add layers to our model. We start by adding a dense layer with 8 units. Think of units as little computational blocks. We use the ReLU activation function, which helps the network learn complex patterns. Since this is our first layer, we need to specify the input shape, which is 4. This means our data has 4 features. Next, we added another dense layer, this time with 5 units and ReLU activation function. This layer automatically receives input from the previous one, so we don't need to specify the input shape again. Finally, we added the output layer. This layer has 3 units because we have 3 classes in the Iris dataset. We use the softmax activation function here to get probabilities for each class. With our layers set, let's compile the model. We specify the loss function as categorical cross entropy, which is suitable for classification tasks. The optimizer we are using is Adam, a popular choice for training neural networks. We also want to track the accuracy metric during training. Now it's time to train our model. We feed it to our training data, specifying the number of epochs and the batch size. Epoch is 200 and batch size 5. Once training is done, we evaluate our model on the test data to see how well it performs on unseen examples. And there we have it. Our model is trained and evaluated. Let's print out the evaluation score to see how well our model to performed. The accuracy is 0.31 and loss is 1.39. All right, let's dive into building our third model, which we'll creatively called model 3. Now, before we go into the nitty-gritty, let's understand what is going on. First off, we start by creating a sequential model. Think of it as a blueprint for our neural network. We are going to stack layers on top of each other, like building blocks. After training, it is evaluation time. We want to see how well our model performs on data it hasn't seen before, our test data. We calculate a score that tells us how accurate our model is. After training, it is evaluation time. We want to see how well our model performs on data it hasn't seen before. Our test data. We calculate a score that tells us how accurate our model is. And there you have it. We have built, trained, and evaluated our third model. Now let's see how well it did by printing out its score. The accuracy is 0.87 and loss is 0.19. Compared to the Model 2, the accuracy of Model 3 is increased.